All right, next two theorems that we have here. Theorem 3 is the antiderivative of 1 over x. This is sort of the exception. Remember up here the power rule doesn't apply for n equals negative 1. And if n equals negative 1, then x to the n is x to the negative 1, which is 1 over x. So this covers everything except for x to the negative 1, which is algebraically the same as 1 over x. So this rule right here talks about that case. So the antiderivative of 1 over x is the natural log of absolute value of x. So that absolute value of x is important. Okay. It's because 1 over x, its domain is this expression here, but the natural log of x, its domain is only positive numbers. So there has to be that absolute value there to fix things. Another theorem here says that you can distribute the integral exactly like you would with a derivative. So you can do, the integral of two things added together is the two integrals added together. If you have a constant, you can factor the constant out front. Okay? So let's take a look at these integrals. Here we would have 3/5 x to the 5th minus 5, and I usually leave a little bit of awkward space here, and then I will determine my new exponent, which will be 5/3, and then I will multiply by that fraction, which is going to be the reciprocal, 3/5. Plus, same thing here, we're going to have x to the negative 2. We're going to divide by negative 2. So whether you want to write it as adding negative 1/2, doesn't really matter. In this case, I do like to simplify this and get negative 1/2. I don't like to write the redundant plus sign there. And of course, you can clear this up. You can cancel the 5s here if you'd like. Part B. Here, this first term is really, we can think of it as 5 times the integral of 1 over x, which is 5 natural log absolute x. So this would be 5 natural log absolute x minus 3. We're going to have something here times x to the negative 9. This will be negative 1/9 plus c. For these answers, I'm not requiring that you simplify. Feel free to, but really we're just trying to get through the rules here.